All right, so before we do the VR thing, I want to go over a little bit of math because what we're going to do is we're going to do this really cool project on glaciers and stuff, but there's math involved. So let's read, you guys settle down. Let's read this. It says, Stanley, Idaho is considered Stanley, Idaho is considered one of the coldest places in the United States. A group of friends decided to go overnight camping on an overnight camping trip in Stanley in January and measure how the temperature drops throughout the night. They first started measuring the temperature when the temperature was exactly 0 degrees Fahrenheit and then checked the temperature every hour after that. They found that the temperature dropped the same number of degrees every hour. Complete the table to find out the temperature for the first 4 hours. So here's the trick. We need to fill out this table. So what they're saying is 0 hour at the very beginning, the temperature was 0 degrees, right? Then after 2 hours, it was negative 12. And the temperature drops. It's the same amount every hour. So what goes in here? 6. Well, you're half right. Negative 6. So now let's, has everybody got a calculator? So that means that, I want you to think about this. What do I do to get from 0 to negative 6? No. Subtract by 6, right? What do I do to get from negative 6 to negative 12? Subtract by 6. What do you think we're going to do again? Subtract by 6. Okay, so get out your handy-dandy calculators. And I'm going to take negative 12. Let me clear this so it's a little bit higher up. I'm going to take negative 12, and then what? Minus 6. Very good. That's negative 18. And let's do it one more time for the fun of it. And negative 24. So the next two numbers are negative 18. And then we subtract 6 again. And we get negative 24. How do you guys feel about that? Thumbs up, thumbs down? Do you have this written down? Let's write this down. Quit touching the person in front of you and write it down. Let's go. Do you have this written down?
I like touching me.
Okay, well, I'm recording, so there's that. Now we need to plot the points. Now, those points are going to be 0, 0. And then the next one was 1, negative 6, right? And then the next one was 2, what was the next one? 12. 12. And what's the next one? 3, 18. And then what was the next one?
Negative 24.
Negative 24. Okay, cool. Do you guys remember how to plot and graph points on the graph?
Yeah.
Remember, the x-axis goes left to right. The y-axis goes up or down. If it's a negative number on the y, you go down, right? Going up is positive y value, and all of our x's are positive, so we go to the right. So the first point, 1, negative 6, it goes to about right here. Just make a big dot there and say negative 1. Oops, not negative 1. What goes in there? 1, negative 6, right? And then from there, the next one is 2, 12, which would be, or negative 12, which would be about right here. 2, negative 12. And then the next one, what do I plot? 3, negative 18. Hey, what do you notice about all these dots that Mr. Adams is plotting? Yeah, they're making a straight line. So 4, negative 24 would be about right here. What do you guys think of that? I'll give you a second to finish writing that down. Thumbs up if that makes sense. Thumbs down if you're really confused. If you're somewhere in between, that's okay. No, like legit. I need thumbs up, thumbs down. Let's go. Thumbs up. He's tying his thing again.
Okay.
All right, so let's go to the next page. It says number 3, what is the slope of the line? All right, here's how we figure out the slope of the line. Slope, as you may or may not recall, is the rise over the run, and we could do that mathematically. Here comes the fancy algebra stuff. Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now remember the points, I'm going to pick 2 points. I'm going to pick 0, 0. Remember these are x's and y's. So I'm going to say if that's my x1 is 0 and my y1 is 0, that's cool. The next point was 1, negative 6. You should be writing this down. I'm going to collect this for a grade when I'm done here. Then that means that x sub 2 is equal to 1. What's y sub 2? Well, negative 6. Thank you. So that means to plug this in the formula, I'm going to say negative 6, which is y sub 1, y sub 2 minus y sub 1, which is 0, all over x sub 2. What's x sub 2? Go. X sub 2, look on the screen. X sub 2 equals? No, it's not Steve. Quit being funny. What is it? Look on the screen.
Brett, right there, Brett.
I don't know.
Brett, it's literally right there, Brett.
5?
Brett, hey, the one on the
Bro, actually.
I'm going to play this video for the assistant principal.
5 minus 7.
What is x sub 2 equal to? Look. X sub 2 equals...
1.
There it is. Whew. Man. All right. So then if we do the math, I get negative 6 over 1. Negative 6 over 1 is just negative 6. So m is equal to negative 6. It says if I were to write an equation for this, remember that for a straight line, it's y equals mx plus b, right? Well, b is when x equals 0 and y equals 0, so my b, or the y-intercept, is equal to 0. Make sure you're writing this down. And we said that the slope m is equal to negative 6. Correct?
Yeah.
All right, so my equation is y equals m. What's m equal? Negative 6. Very good. And then I put the x down. Do I need to write plus 0? No. So this is our equation of the line. Now sometimes we could write that in function notation, and I could say f of x is equal to negative 6 times x. Okay. Well, what would the temperature be at hour 5? What do you think we need to do for that? Minus another 6, or we could use the equation. Could I do this? Could I say the function evaluated at, well, x, yes, but we're going to say we're going to let x equal 5, right?
Yeah.
Is equal to negative 6. What do I plug in here? If I had an x here and I put a 5, what do you think I put here?
5.
5. What does that equal?
35.
No.
Negative 35.
No. Let's do this. Negative 6 times 5 equals, you guys, it's negative 30.
I said that.
It's okay. I've got a negative 30 here. So now if I were to plot that on the graph, that means that when x equals 5, y equals negative 30, correct?
Yeah.
Yes. All right. So now it says if we had to rewrite this equation as T of H, how would I write that? So I want you to look at this equation. How would I rewrite that? What would you write down here? Same equation, we're just changing some of the letters around. In other words, we're going to say the temperature is a function of the hour. What would you put if you were to guess? And I'll let you in on a clue. It's got to look sort of like this.
So,
T of H is equal to...
So the TH equals -6.
Not X. You're close.
Or
negative 6H.
Very good. Negative 6H. Oh,
What's that?
why do I feel like I've been through a lot? I feel traumatized. Any questions on that?
No.
So if I got a question for you guys though. If I wanted to know the temperature after 8 hours, what would I do?
Minus 6, minus 6.
No. No.
Plug it in.
Plug what in?
8.
8 for what?
The X, the H.
H. Very good. Very good. You guys get that?
Yeah.
So we came up with an equation that if I plug in the hours as H, right? So if I let H equal the number of hours and I say 8 and I plug it in, that'll tell me the temperature after 8 hours, if the trend continues.
Yeah.
Correct? All right, good. All right, put your names on those. Put them in the inbox real quick. Come back to your